In this video, we're going to learn how to simplify a natural logarithmic expression. Now, what is a natural logarithmic expression or a function? It's anything that's log base e, and e is that number we learned about in a previous lesson. Now, whenever you have a log that's base e, we call that a natural log. So the way you would read, for example, the first example is 2 natural log of 15 minus natural log of 75. And you just write it as ln for short. Now, just so you can read this expression, because we'll use ln of x whenever we write it, y equals natural log of x means that y is the exponent. You raise the number e2 to get the number within the natural log. So that's the definition of ln of x, or the natural log function. So let's write each expression as a single natural logarithm. So as first example, we have 2 natural log of 15 minus the natural log of 75. So they're being subtracted, and I want to combine them by using division within the log, but there's still a coefficient in front of my natural log. So I need to move that within the natural log first. So I'll have natural log of 15 squared minus the natural log of 75. Now, 15 squared is 225. So we'll have the natural log of 225 minus the natural log of 75. And now it's set up for me to combine these two using division, because they're being subtracted. So I'll get the natural log of 225 divided by 75. And 225 divided by 75 is 3. So this just simplifies to the natural log of 3. So by definition, this number here, just to go back over it, is the power you would raise e2 to get 3. So that's the exponent you raise e2 to get 3. So next up, I want to combine these two natural logs. They both have coefficients, so I'm going to move them into the natural logarithm by making them exponents. We'll have x to the third, natural log of x to the third, minus the natural log of 2x squared, the entire expression squared, which means we have the natural log on the right of 4x squared, because you'd also square that too. And now that they're being subtracted, I can combine them even further into the natural log of x to the third, my numerator, divided by 4x squared, which can simplify to the natural log of x in my numerator, because 2 of the x's cancel, over 4. Now let's look at this top example on the right. We have 3 natural log of x plus 2 natural log of y plus the natural log of 5. I'll move all those powers in to the natural logarithm as exponents, all those coefficients. So we have natural log of x cubed plus the natural log of y squared plus the natural log of 5. And they're all being added, so they'll all be multiplied together. Give me simply natural log of 5 x cubed y squared. Since none of them were being subtracted, nothing should go in the denominator. Now this time I'll put the number e within a natural log, and we'll see what kind of effect that has on its final answer. So first we'll move these coefficients within the natural logarithm. So we'll have the natural log of 4e squared cubed minus the natural log of 8e squared. Now when you cube 4, you get 64. So we have natural log of 64. And then e squared cubed is 2 times 3, so e to the 6th. Minus the natural log of 8 squared, which is also 64. And then e squared, which is just e squared. Now they're being subtracted, so I can combine these into one natural logarithm with division. So I'll have natural log of 64 e to the 6th over 64 e squared, which just gives me the natural log of the 64's cancel, and e to the 6th divided by e squared. 2 of the e's cancel in both, give me just e to the 4th. Now, what is the natural log of e to the 4th? Now, if we were to read this expression, the natural log here, this number is equal to the power you raise e to get e to the 4th. Now, what power would that be? Well, obviously, it's the 4th power. So we can rewrite this as just 4 for its simplification. Again, the natural log represents that exponent I raise e to get the inside number, e to the 4th. So the number you would raise e to get e to the 4th is obviously 4. Now for the last example, they have coefficients, but the things in parentheses don't have coefficients, so I can actually combine those to start, giving me 1/3 natural log of xy minus 4 natural log of z. Now I have this one natural log being multiplied by 1/3, this other natural log being multiplied by 4. That can become an exponent within the logarithm. So I'll have natural log of xy to the 1/3 minus the natural log of z to the 4th. Now they're being subtracted, so I can combine them into one, give me natural log of, in my numerator, xy to the 1/3, and in my denominator, z to the 4th. Now the 1/3 power is a cubed root, so a better look for this expression would be the natural log of the cube roots of xy divided by z to the 4th. And that is how you simplify a natural logarithmic expression.